the cross product has another name which is called vector product. Do you still remember the dot product? The dot product, you have vector A dot vector B. So vector A dot vector B, the result gives you a scalar, but cross product, the result is a vector. So we have two vectors A and vector B. Vector A, three-dimensional. We have A1, A2, and A3 three component. Same thing in vector B, B1, B2, and B3. So here is a cross product. We have vector A cross vector B that is equals to this. You have to get used to it. So this is vector A2 times B3 minus A3 my A3 times B2. So A2 times B3 and then minus A3 times B2. And then comma A3 times B1 minus A1 times B3, comma A1 times B2 minus A2 times B1. I know the pattern is not obvious. This is something that you will have to memorize. But what is the cross product represent? The result is a vector, but cross product is a binary operation on two vectors in a three-dimensional space. Vector A cross vector B is a vector that is perpendicular to vector A and B. So here is a picture. We have vector A, we have vector B. This is the angle between vector A and vector B. And then this cross product, so we will have to use three-dimensional space. This cross product, this is vector A cross vector B. This vector is perpendicular to vector A and vector B. So cross product is actually a vector, but when you find the dot product of two vectors, the result is a scalar. Okay, to do cross product, we will have to review the determinant. So a determinant of order 2. So a determinant of order 2, you can think about the determinant of a 2x2 matrix. So let's say we have A1, A2, and then B1, B2. So the determinant is you just cross multiply like this. A1 times A2 minus A2 times B1. So A1 times, did I say this right? A1 times B2, you multiply this, and then you multiply A2 times B1, and then you subtract the result. This is on a 2x2 matrix, but in a cross product, you will have to use the you will have to deal with a 3x3 matrix. So this one, we call this a determinant of order 3. So here is how that works. A1, A2, and A3, B1, 2, and 3, C1, 2, and 3. So you will have to put the A1, A2, A3 like that, and then be careful, this sign is a minus. So how about the little 2x2 matrix? So here is the pattern. B2, B3, C2, C3. Do you see this? B2, B3, C2, C3. And then, how about the next one? The next one is A, B1, B3, C1, C3. So in the 3x3, this is what you will have to take. And then finally, you have B1, B2, C1, C2, which is right over here. So here is what we have to do. Let's review this order. Let's review the process again. First of all, we have A1, A2, and A3. You write this down. A1, A2, and A3. Be aware that the second sign is a minus. That's why I put the minus in red to remind you. And then, how do we pick up the 2x2 matrix? First, we pick this. And then second, we pick these two. And then finally, we pick this. And then the result is a determinant. So let's put this on a real problem. So we have two vectors A and B. A is 3i plus 3j minus 3k, and then vector B is 3i minus 3j plus 3k. So how do you find the cross product? So to find the cross product, we are going to do this. So we have vector A cross vector B that is equals to, so we write the matrix first. We start with I, j, and k. I, j, and k. And then we write the components, positive 3, positive 3, negative 3, and then vector B, positive 3, negative 3, positive 3. All right, and then that is equals to I times what? Where is my 2x2? My 2x2 is right over here. Bring it over. 3, negative 3, negative 3, 3, and then minus j. Where is my 2x2? My 2x2 is right here. This and that. So 3, 3, negative 3, 3. Okay, go ahead, write this down. 3, 3, negative 3, positive 3. And then plus k. Where is k? K is right over here. Okay, write this down. We have 3, 3, and then 3, negative 3. All right, and then what goes next? The next one is you will have to find the determinant of these two, the 2 by 2 matrix. So here is how we are going to do it. We cross multiply like that. Cross multiply like this. So the first one will be, I should draw the line one by one. You multiply this 3 and 3. So 3 times 3 is equals to 9. And then this negative 3 times negative 3 is equals to negative 9. So it's equals to positive 9, sorry. So you are subtracting the second product, subtracting this product. And then you minus j, and then you cross multiply again. 3 times 3 is equals to 9. And then you subtract. 3 times negative 3 is equals to negative 9. So you are subtracting a negative 9. And then plus k. And then what do we have? We have 3 times negative 3, which is negative 9. And then minus is always a minus. And then 3 times 3 is positive 9. Okay, so write this down. So 9 minus 9 is gone. So this one is negative 18j. And then what else? And then minus 18k. And then what else do we can we answer? So here is what we are going to do. First I want to find the cross product. So this is cross product. And then the next thing that I would like to find is verify that it is orthogonal to vector A and vector B. So make sure that the cross product is orthogonal to vector A and vector B. So if this cross product, which is vector A times vector B, and then multiplied by vector A equals to 0, then they are orthogonal, right? Okay, so how are we going to do this? We have the cross product. The cross product is negative 18j minus 18k. And then we dot the product, we dot the vector A. Vector A is equals to 3i plus 3j minus 3k. Okay, how do we perform this operation? Basically, we take the we take the number in front of I, j, and k, and then we multiply them. So in the first parenthesis, do we have a number in front of I? No, then we have a 0 times 3, and then we plus negative 18 times 3, because they are both in front of j, and then plus negative 18 times negative 3. And then what is that equal to? This one is equals to 0 minus 54 plus 54, that is equals to 0. So they are orthogonal. The cross product, which is the vector, is orthogonal to vector A, because that is the cross product, right? So the cross product must be orthogonal to the vector. And this is a cross product of A and B. So when we show the other one, that is going to be orthogonal to vector B as well. Okay, so orthogonal. What is next? Let's do this for B. So if cross product of A times cross product of B times vector B, that is equals to 0. So the cross product is negative 18j minus 18k, and then we multiply vector B. Okay, vector B, you don't need to rewind the video. I will write it down for you. 3i minus 3j and then plus 3k. All right. Okay, so I, there is no I in the first parenthesis, so 0 times 3, and then plus negative 18 times negative 3, and then plus negative 18 times positive 3. So obviously, they got cancelled, right? So this is a 54 minus 54 equals to 0. So everything we did was successful. The cross product is orthogonal to vector A and vector B. because that is how the cross product works. The cross product, you need two vectors, right? A and B, and then the cross product by definition, by the definition of what it is, what is the cross product? The cross product is a vector that is perpendicular to vector A and vector B. All right, so let's make something harder. Let's move on to the next vector. The next vector, we have a bunch of sine and cosine. Okay, how do we find the cross product? So here is how we are going to find the cross product. I'm trying to match the color. That is a perfect match. So we have vector A cross vector B. That is equals to, first we put down the I, J, and K. So I, J, and K. And then we have T, cosine of T, and then sine of T. 1 minus sine of T, and then cosine of T. Okay, now let's do the determinant. So this is I, and then we write the 2 by 2. The 2 by 2 is where? It's right over here. All right, copy it over. You have cosine of T. You know what? When we go back and forth like this, I have to keep track on the pen, the highlighter and the pen. So cosine of T. Close that. And then this is always a minus for the J. For the J, we take T and 1, sine of T, cosine of T. And then the last one, the K, is always a plus. For the K, we take this piece. All right? T1 cosine and then negative sine. Okay, wow, the next line is going to be very, very long. Okay, write the determinant. So we have I cross multiply. Cross multiply, this will return to a parenthesis. Cosine times cosine, like this. Cross multiply, here. Cosine times cosine, sine times negative sine. You should use a highlighter to put this on your papers, and then you do this for every single one of them. And then cosine times cosine is cosine square of T, and then is always a minus. So when you have a minus, then you have a negative sine square of T. And then minus J, T times cosine T, and then minus 1 times sine of T. And then plus K, T times negative sine of T, and then plus 1 times cosine of T. There you go. And then what else? What is next? The cross product is right over here. And then we have to prove that the cross product multiplied vector A is equals to 0. So we have to take this. What is vector A? For vector A, you know what? For contrast purpose, I am going to put vector A right over here. So the vector A is you don't need to rewind the video. I will write down for you. The vector A is Ti plus cosine of Tj, and then plus sine T of K. So we take everything in front of the ijk, and then we multiply them accordingly. Okay, let's do the first multiplication. So here is the first multiplication. The first multiplication is you will have to take this piece, multiply T. So you will have to take, hold on. Did I make a mistake right over here? Oh, you know what? Yeah. Everything I wrote so far is not a mistake. So what I should do more is I should simplify the cross product. Okay, you know what? Nothing is a mistake. So I will just copy this and then move this down. Nothing is a mistake. I will just move this down because I would like to simplify this. This line is very important because I don't want this to be negative. Okay, let's do the simplification. So that is equals to, okay, cosine square plus sine square here. this one is a plus, right? Cosine square plus sine square, you still remember your trigonometry, that is equals to 1. And then for the j, so here is how I'm going to take care of the negative. I am going to factor out a negative from the parentheses. So I'm going to do a plus j. And then inside the parenthesis, you will have the minus sign becomes a positive. So we have positive sign of t minus t cosine of t. And then for the k, we are not going to do anything. For the k, we will just do this. For the k, I will just do negative t sine of t plus cosine of t. All right. And then I think we are going to do a lot of looking. So this one, I am going to copy it. And then I am going to paste that over here for my convenience. So at this point, I am going to dot these two vectors. I am going to do a dot product for this and that. So the cross product dot vector A. So for vector A, I'm going to say that this is vector A. Okay, so let's do the multiplication. It's a lot of work. This is a very long problem. Okay, so what we are trying to do next is when you do the dot product, you take the number in front of I, j, k and then multiply them accordingly. So for the first one, I am going to take the 1 right over here to multiply the t. So take 1 times t because they are both in front of I. So the dot product is equals to, we have 1 times t. And then we have the multiply, the cosine, and this parenthesis. So that will be a little distribution, right? So we have a cosine t times sine t. So we add sine t, cosine of t, and then we minus t times cosine square of t. And then we subtract sine times sine. So we have here, I'm going to be extremely careful right over here. So we have a negative t sine square of t, right? And then sine times cosine. And then we, okay, I need to make sure that there is no mistake because this is, I wrote a plus. Is this really a plus? Huh? Is this really a plus? The last one, the k. Let me double check my work. I am sure that that is not a plus here. Co t times that, and then here. Oh my god. Here. This is a minus. Oh, I'm glad that I found this out. If I didn't find out this problem, then I'm not going to get a, I am not going to get a 0. So this is a minus, and then this is a minus then. Okay, good. Okay, we continue. And then we subtract sine of t, cosine of t. Do you see why I find out this mistake? Because this will be cancelled. This will be cancelled. And then what else? You have a t, right? And then the sine square, cosine square, as long as you take a t out, you have cosine square t plus sine square of t. Then that is equals to be a 1. So we have t minus t, that is equals to 0. All right, so the cross product is orthogonal to vector A. Whew. We still have one more to go. Now we have to do the cross product and then dot the vector B. So we have to do the cross product A cross B, and then we have to dot product vector B. Okay, what is vector B? Vector B, I'm going to bring the vector B up for you. So the vector B is I minus sine of tj and then plus cosine t of k. Okay, what is that equal to? This one is equals to, where is my cross product? My cross product is right over here. So we have a 1 times this one. So we will have a 1. And then minus everything in front of the j multiply. So we will have to multiply this piece to here. The sine multiplied by that. Take a look. Sine multiplied by that. Look at my circle. Okay, let's do the math. So we have minus sine square of t and then plus t sine times cosine, right? So plus, is it? No, t. Yeah, t and then sine times cosine. Alrighty. And then we do the k. The k here is the circle that you are looking for. We multiply this. And that cosine times the circle right over here. Okay, let's do the multiplication. It's a lot of looking. And then cosine times negative t sine t, so that is negative t sine cosine. And then plus minus is a minus cosine square of t. Okay, what can be cancelled? Obviously, that these can be cancelled. And then we have that, we have 1. I'm going to do the same trick, factor negative out, sine square plus cosine square, that is 1. So we have 1 minus 1 equals to 0. What does this mean? What that means is the cross product, this vector, is orthogonal to vector b, and now this is the happy ending. That is the end of this video. If you like the way I introduce cross product, if you think I picked a good problem for discussion, give this video a like. If this is something that you want to see, give my channel a subscribe. As always, I will see you all in the next video. Signing out.